part of the demo, we would like to show you a couple of unique and differentiating tools that Code Composer Studio Desktop provides that would allow you to further optimize and enhance your application on MSP products. So let's go ahead and open CCS at this point. Just like I showed you earlier, within CCS Desktop, we also have access to the TI Resource Explorer. As you can see here, you can see the same and similar navigation tree. So MSP where content is all provided, and again, they organize in the same way: devices, development tools, as well as libraries. So for the demos of the next two tools, which are EOP Advisor as well as Energy Trace, let's use one project example. This example is actually part of the MSP432 deep dive training. So let's find out under devices, MSP432 P4XX. So this is a training, as I mentioned earlier, this is a 1.5 days worth of training that really gets you deep inside the details of MSP432. And then the first lab that we will use today is called Power. This specific example gives you a better understanding of how different power modes work, how to leverage different low power modes on MSP432. So once you import that project inside CCS, we will use this as an example to show how EOP Advisor as well as Energy Trace work. So EOP Advisor is a static code analyzer that actually scans through your entire project code and detect any areas in your code that could use some improvement in terms of power consumption. So as an example, if you leave a pin floating, or if you spin your device in an empty loop, and the CPU is constantly running, you might consume more power than you actually should. So the so EOP Advisor can actually detect for such lines of code, and it will highlight it for you. So the way to enable EOP Advisor for any of your CCS project is actually just go ahead and go to Project Properties, and you can find the EOP Advisor tab in there. So once you select all of the rules in here, you can actually learn more about what the different rules are. For example, the first rule will detect if you use low power modes in your application. The number 3 might find out whether you are leveraging interrupts and go to low power modes as opposed to just constantly waiting in loop and checking a flag, for example. The rule number 4 is my favorite. This rule detects if you fully initialize the entire device or you are still leaving some port pins floating, which can potentially consume a lot of power. So once you enable all of these rules, go ahead and build your project like you normally would. So what happens is during this project building phase, in addition to compiling code and linking everything together, the tool CCS actually also scans through the code and highlighting all of the lines of code that could use some improvements. So as you can see, it has already found 3 different lines of code that, as I said here, there is a software delay loop that is using an empty loop. Maybe you can actually go to low power mode instead. So once you double click on that, it will actually point you directly to a line of code that needs to be that could be adjusted. So obviously, not everything should be changed. Sometimes you need to sometimes you just need to write the code that way. But at least with this tool, it will give you the opportunity to review areas in your code where you can make adjustment or improvements if needed. So let's fast forward through this code compilation process, and it's now, if you go under Advices, you can see there are multiple advices being listed here, and it's up to the developers to go back and assess whether I need to go back and address any of these EOP rules to further improve on their project. So EOP Advisor is a great way doing code development to make sure that what you write is power efficient. And the best way to confirm or validate that whatever changes you made to your code actually gets you the power saving you need is to have a way to debug or measure energy and current live while debugging your code. And actually, Code Composer Studio introduced another tool that does exactly that, and that tool is called Energy Trace. So Energy Trace is a brand new technology that TI created that enables developers to measure the energy of the application in real time and correlate that energy measure directly to what's going on in the code, as well as what is actually consumed that power. So this tool will come hand in hand and pair really well with EOP Advisor. So let's go ahead and get started. So you might see that there is one icon here. It's called Energy Trace Technology. And if you click on this button now, it will launch a standalone energy measurement session. For our demo today, we would like to run a debug session first and measure energy so that we can see the correlation between what's happening in the code and how that consumes, how much power that consumes. So once the debug session is ready for you, you can go ahead and click on Energy Trace Technology window. This will open up a new set of window. In here, you can configure a number of things. First thing is, do you just want to measure energy, or do you also want to measure the debug state and correlate the two information with each other? So once you select this mode, you can see there are 4 tabs in total. The state tabs, which shows when the device stays in active mode and when the device goes to low power mode. The energy tab shows the entire device consumption, energy consumption over the entire period of measurement. Very similarly, the power tab shows you the power being consumed at any given point during this time. The most important tab though is Energy Trace Technology. This is where you can actually configure a number of things and see exactly where in the code the device spends the most time in, and what functions actually contributing the most to the power consumption. A couple of things you can also configure here is, let's say, how long you want to measure it for. Let's say for our demo, let's measure for 30 seconds. So now everything is ready for us to start the debug session. So in this demo, we will actually use the button on the launchpad to cycle through different power modes. So I will flip over to the power view. As you can see, as I start pressing the button, the device will wake up, go to a different power mode, and then go back to waiting for another button interrupt. You can see that every time I press the button on the launchpad, the LED blinks for a number of times, and that correlates exactly to the spikes that you might see in the power graph. That is due to the LED current consumption. So as you can see, now after the 30-second window period, you can see when the device is in active mode, when it's using a different regulator which consumes less power, how many pulses of LED that are there for each button press, and how much power is being consumed. So let's zoom it a little bit bigger so you can see the different details in here. Now let's go back to the Energy Trace Technology tab. In this tab, you can see that exactly how much time is being spent in each function. So you can see all of these functions are being used at some point during the application measurement window, but most of the time the device spends in main, which is the main function. So having some idea of how much power is being consumed and having the knowledge of when it consumes how much power and where exactly in the code it consumes that power gives the developers the ability to go back, find the line of code that consumes the most power and figure out, can I do something better about it? And once they make the changes in the code, once they follow the EOP Advisor rules to improve the code, they can actually go back, remeasure the power consumption or energy consumption over this period, and you can actually compare 2 different profiles to see exactly how much power is being saved. So this summarizes a quick demo of Energy Trace Technology as well as EOP Advisor tool. These are 2 really unique ultra-low power tools that were developed by the MSP and TI teams. With these 2 tools, they go well hand in hand to allow developers to, first of all, improve power consumption, improve the software code, and instantly verify that and validate that based on real-time energy measurement.